So, new section, and that is on perpendicular and parallel lines. We're still within this topic of linear relations. We're looking at lines, and specifically on this occasion we're looking at perpendicular and parallel lines. Well, let's look at parallel lines first, because I think there's a good deal of knowledge about parallel lines. You'll often see arrows on parallel lines to denote parallelity. I don't think that's a word, but let's continue. Parallel lines. What we want to do in particular here is to investigate the relationship between the gradients of parallel lines and perpendicular lines. Now, the gradients of parallel lines are the same, so let's make a note of that. Parallel lines never intersect, and their gradients are equal. Okay, so if we know that two lines are parallel, we can go ahead and assume that their gradients are equal. Okay, now moving on to perpendicular lines. Well, it's not quite so straightforward with perpendicular lines. Hopefully we understand that perpendicular lines are intersecting lines, but they intersect at 90 degrees. So if we have a look at let's have a little experiment here where we're looking at say a line that's got a gradient of 1, which is that one there, going across one and up 1, across one up 1, so it's got a gradient of 1. Let's have a look at its perpendicular. So at a 90 degree angle, you think, okay, well, it's going to have to do this, isn't it? It looks like it's going to have a gradient. I can draw a semi-straight line here, that would be very nice. And that is a terrible, terrible line. You get the idea there. The gradient is -1 here. Okay, well, the first thing we should note here is that perpendicular lines have to have gradients with opposite signs. So one's going to be positive and one's going to be negative. That's something to take note of. So what happens though, what is the relationship between them? Let's have a little look here. If this line with gradient of 1 becomes a gradient of 2, so we go across 1 and up 2 now, each time, to form a line of gradient 2. So as this line comes down, across 1 down, this one down 2, so it's doing this all the while. This now has a gradient of 2. Now what about its perpendicular friend? What does it do? Well, now to be perpendicular to that, this green line is going to have to flatten out. In fact, it's going to have to go across 2 and up 1. Across 2 and up 1, if you think about it, it makes sense that it will do that. And so we've got a nice line coming through here, across 2 down 1, so it joins up there, across 2 down 1. And it's doing something like that. So now this green line here, new green line, is parallel to that and has a gradient of -1/2. If you look at it, so any section of this, it goes up 1 or 2 across. So the gradient's -1/2. Okay, so our perpendicular lines, they look like there's a relationship between them, and that is 1 and -1 are perpendicular, 2 and -1/2 are perpendicular. And if you look at the products of those, so 1 times -1, well, that's equal to -1. Let's have a look at these two lines here where the red gradient was 2, so we multiply the gradients together because I think there's a little pattern. Multiply it by its perpendicular gradient there in green, which was -1/2. Lo and behold, we get -1. So that is in fact a relationship. The gradients of perpendicular lines will multiply to -1. So let's make a note about that. Perpendicular lines intersect at right angles. And this is the important thing here, their gradients multiply to -1. Excellent. Another way of looking at that is they are the negative reciprocals of each other, and we're also going to write that down because that's really useful. I.e., that is, they are the negative reciprocals. Let me explain what that is of each other. So, for example, a line has a gradient of 1/3. Therefore, the line that's perpendicular to this line has gradient -3/1 or just -3. So let's just be careful here. Negative, we understand their signs are different. Reciprocal, just to remind you, a reciprocal is a numerator denominator switch. So the reciprocal of A over B is B over A. So the reciprocal of 1/3 is 3/1. The negative reciprocal is -3/1 or -3. So just to summarise, parallel lines have equal gradients. Perpendicular lines have gradients that are the negative reciprocal of each other. The same way of looking at that is that they multiply, the gradients multiply to -1. So, how do we use that? Well, let's look at a couple of examples. Find the equation of the line parallel to y equals 2x plus 1, passing through, let's say, point 1,3. So let's have a look at how to do this question. We're looking for the equation of a line that's parallel to this one. So the line that we want, the line that we're trying to find the equation of, has a gradient that is equal to this gradient, and that is 2. So our line has a gradient of 2 and it goes through 1,3. So we now go and use our y minus y1 equals mx minus x1 formula to find the equation of the line that we're after here. So we put in, this is my x1 y1 here, so it's y minus 3 equals, I'm going to use m equals 2 because I'm after a line that's parallel to this one here, and this gradient is 2. X1 is 1, so we just sub in those points. So y minus 3 is equal to 2 by x minus 2, and if we just tidy this up, we get y is equal to 2x. We add 3 to this side here, and we get y equals 2x plus 1. That was 2 by 1 is 2 plus 1 is 3. Actually 1,3 lies on this line, so that was a terrible point to use, because all we did was find the equation of this exact same line because 1,3 lies on that line. So that was unfortunate. Okay, let's do, that is the method is sound though. Let's have a look at another example. Find the equation of the line perpendicular, let's do a perpendicular question, to, let's say y equals 2/3 or minus 2/3 x minus 1, passing through, let's hope I use a point that's not actually on that line. Let's say the point is 1 minus 1. Okay, so how do we do this? Well, we want an equation, we want a line that's perpendicular to this one. So our gradient, well, this gradient is minus 2/3, but we want the line that's perpendicular to this. And what we've just learned earlier is that perpendicular gradients are the negative reciprocal of each other. So our gradient, our line, has gradient equal to not minus 2/3, but 3/2. The reciprocal of 2/3 is 3/2, and we want the opposite sign, so that's positive 3/2. So our gradient is 3/2. Our x1, y1 is here, 1 minus 1. And now we're going to go and find the equation of this line using this formula here. Y minus y1, so it's going to turn into y minus minus 1, or y plus 1. 3/2, which is our gradient. X minus x1's up here at 1. Now at this point we should always look to multiply now through by 2, because that's our denominator here, and we can eliminate that denominator by multiplying by it. Now we are just doing some algebra. I think the neatest way of representing this would be to say that 3x minus 2y minus 5 is equal to 0. So that is the equation of the line that is perpendicular to this line. And the gradient there, this line is minus 2/3, so our gradient is 3/2. Going through 1 minus 1, we'll construct this algebra here, and there's the equation of our line. Okay, I'll see you in class on Monday.